Hello, everyone. Welcome to Ruminate This with Agrarian Solutions. Join us as we explore ruminant nutrition and the impact of mycotoxins. Here, we challenge your curiosity and explore new industry insights and research to optimize your herd's health and performance. All right. Hey, everybody. Welcome back to Ruminate This with Agrarian Solutions. I'm your host, Scott Zehr, and today I'm going to be joined by Miss Caroline Knoblock, our Director of Nutrition here at Agrarian Solutions, and we are going to be having a discussion with Caroline around mycotoxins. Caroline, you had the opportunity recently to present at the Penn State Nutrition Workshop. We did a breakout session there. One question I would have is, what did you think of the breakout and the, reception from your presentation? And two, what's maybe your initial take home from the presentation?
Well, I enjoyed doing the breakout a lot because I've been going to this conference for years and I've really enjoyed the different breakout sessions, the different options we have to choose what we want to learn about during the week. So I was very excited then to be able to have the opportunity to talk and, to represent Agrarian. But what Penn State wanted from us is just kind of not product talk, more basic nutrition and just science knowledge, which we were very happy to do. So the presentation really just focused on kind of the basics of mycotoxins and really what they're doing in the animal's gut and kind of how they're interacting with the animal. And, why does that matter for dairy nutrition? Why does it matter for the health of the animal? Why do we need to be measuring mycotoxins in feeds? Also then went into mitigation strategies. So from the field all the way to the animal, and had really good attendance. I was really pleased. There were some really awesome talks during the time that I was talking too. So I felt very happy that people wanted to come and listen. And yeah, it was a good time. I really liked the interaction afterwards too.
Yeah, no, it's good. I think that's a cool, statement, if you would, about you've had a chance to attend this conference for years. So congratulations to you for being able to get that slot. That was cool. To dive into this a little bit, I just kind of want to walk the audience through maybe a little bit of what that presentation was, because you're right. It's not really a product type presentation. I felt that was a very educational presentation from the standpoint of, I guess the way I framed it up in my head, if you took somebody that had no connection to agriculture, no connection to dairy, didn't know what a mycotoxin was, didn't know why we should be concerned about mycotoxins, just pulled somebody off the street, set them in the back of the room, they could have walked away with a general understanding of mycotoxins, why they matter, and why we should be concerned about them in the livestock world. So I just going to ask you a few questions about mycotoxin mitigation first. Where is the best time, or where are the three places in particular that we can mitigate mycotoxins?
It's good to start in the field. Unfortunately, we don't have things that can directly stop and break down mycotoxins in the field. So mycotoxins are produced by molds. Molds are making mycotoxins just to keep the mold alive. They're not making mycotoxins to say, hey, I'm making this to go after, a cow. It's just something they're making that weakens surrounding organisms, gives the mold a better chance of survival. So in the field, the best thing that can be done is applying fungicides. It doesn't always reduce the mold and mycotoxin load, but it does very consistently increase crop quality and increase yield. Just if it's going to be able to stop that mold growth, it really depends on the applying it at perfect timing, which is really hard to do. So it's using drop nozzle sprayers that are going down in between the rows, kind of getting on the ears of corn, applying it full silking, applying enough fungicide for your number of plants. So it's hard to consistently stop mycotoxins and molds, but it is a good consistent practice just for getting yields.
I want to follow up there with that, because you said something kind of interesting there. I think when you're in the heat of the battle, whether you're feeding beef cattle or dairy cattle, swine, poultry, whatever, we have this mycotoxin issue. And it's like, you have this mentality like, why me? Why is this happening? Kind of thing sometimes when it's bad. But I was actually in conversation with somebody this week, and you talk about the molds, like that the mycotoxins are just their natural defense mechanism, protecting their turf from other molds coming into their area. And yeah, I mean, they're not out there producing Don or zearalenone to intentionally harm our cattle, right?
Yeah.
But one of the comments that we make that I had to rethink, and I'd like your take on this, is, we think of Don as being a cool, wet weather mycotoxin. So we'll say things like Don thrives in a cool, wet environment. Well, actually, it's the cool, wet environment that actually stresses the Fusarium mold that creates
Yeah,
the
that makes
mycotoxin,
sense.
right?
Yeah.
So, yeah, like clarify that statement for us a little better.
Yeah, I think we're just trying to be simple, because trying to get down to like the very base. If you have cool, wet weather, we tend to see more dawn. But yeah, it's all about what is going to be stressing. First, what will stress the plant and allow a mold to proliferate. Because if the plants have protection mechanisms in them, but if they're stressed and that protection is diminished, then the molds can proliferate on the plant. Then the mold is going to be stressed just because of that cool wet weather, or through just simply harvesting it and shaking it up. Then it'll make the mycotoxin to protect itself. So it's, yeah, we kind of get very vague about the molds. And I mean, I think it's also, we're vague because we don't know super specifically how to stop them. So we know which molds produce which mycotoxins, we know which general environments, but there's a lot we don't know. And there's some plant research going on to try to figure it out, but it's kind of, molds exist, they're all around. So really the best thing we can do to stop them is keep plants healthy, which is
Yeah.
why fungicide application can help sometimes, because it
Yep.
helps keep the plant healthier.
Now, what's the role with maybe like plant genetics? Are there things that we can do from hybrid selection to help out?
It's primarily going to be disease-resistant hybrids that might have a better chance at having fewer molds. So there's no, as far as I'm aware, there are no hybrid selection strains that you can choose that have any kind of mold protection or mycotoxin protection.
Yep.
It's just general health traits, because a healthier plant is less likely to get molds on it, therefore less likely to have mycotoxins.
Makes sense. Yeah.
Yeah. So
Yep.
there's a lot of drought resistant crops now that have that trait bred into them or put into them. And that's might be why we see less aflatoxin than we used to. Just because
I think that's
plants are
fair.
not as stressed out in the drought as they used to be. So that mold is just not able to grow as well as much.
Caroline, we've been talking about molds and mycotoxins at the field level. The harvest has been done. We have corn silage in the bunk fermenting. Some farms are feeding that corn silage. We have grain corn that's being fed and distributed all over the country from the 24 growing season. Talk to us about what happens in silage or during that storage phase. We're bringing in mycotoxins from the field as we harvest it. Is there anything we can do in the bunk to lower that level of toxins in the bunk?
Not really. So once you harvest it, the mycotoxins you have are going to be your minimum amount you have. There's really nothing that happens in fermentation that's going to break down a mycotoxin. And there's nothing you can apply that's going to break down a mycotoxin onto the feed. You can have an increase in mycotoxins with storage, because remember, if there's mold growth, it's going to make mycotoxins and you'll get more mycotoxins. So it's anything that can be done in storage to prevent mold growth will help prevent an increase of mycotoxins in storage. So it's all the same comments and advice everyone gives for corn silage. It's packing as much as you possibly can just to get all that oxygen out, a good barrier plastic, and just tires, as many tires as you can fit on the pile. It's just, you want to reduce oxygen so that we're reducing that pH as quickly as possible, because that will limit mold growth. So what you put in is, you kind of stuck with it. It is going to vary throughout the pile just because of different fields and different sections. But if you're packing really well and applying lactic acid based bacteria inoculants can help, because just with the mold growth, it's not going to help with the mycotoxins,
Right.
but those help reduce the pH quicker and help get you a better fermentation and prevent that mold growth.
So what we harvest
Unfortunately,
in is what we have, but
yeah,
there are strategies with packing and proper coverage and even using some inoculates or preservatives that can help reduce the chances of growing more mycotoxins during storage.
correct. Yeah.
Okay.
What you harvest is what you have, but we can prevent more.
Okay. That makes sense. That
Yeah.
makes sense. I kind of want to go into now the cow side of things because at the end of the day, this is where we have the most opportunity, I think, to consistently protect ourselves against mycotoxins, right? And we've been, industry wide, this has been going on for years, right? Dating back to when we first started harvesting, if you would, clay-based binders, stuff that comes out of the ground, different types of products like that. We've been trying to figure out a way for years to take care of this issue inside the cow. And in some cases, those types of products are recommended. But before we get into the mitigation strategies, what is that mycotoxin actually doing inside the cow that happens before we see a decline in production or reproduction or loose manure or so on and so on?
Yeah. So mycotoxins have been around for ever. Molds have been around for forever. So mammals, all animals have been fighting mycotoxins for just millennia. But so what happens is the first place that mycotoxins are really interacting with animals is obviously the gut because they're ingesting them. So if you look at the small intestine of the animal, that's where we're going to be stopping the mycotoxins. That's that castle wall that's protecting the animal. And it's protecting the animal not just from mycotoxins that they're eating, but also other pathogens. That castle wall has a lot of different cell types, but a very common cell type are enterocytes. They're just simple absorptive cells. They're absorbing all kinds of things just through passive diffusion. This can be your nutrient absorbing cells, but these cells are also absorbing things like mycotoxins. They're not going out there and recognizing them and bringing them in. It's just passively they go in because of concentration gradient. So when the cells do have natural defenses though, because they don't want these mycotoxins to go into the body. Have natural defenses that have developed over time. And so what happens is when these mycotoxins get into the cell has an ability to recognize that mycotoxin. And so the cell then builds machinery to kick it back into the intestine. So instead of going from the intestine into the intestinal cell and into the blood, the intestinal cell is kicking it back into the intestine and into that lumen. And that's a good thing. That's how it's protecting itself. What happens now, because we have so much more exposure to mycotoxins, our animals are exposed to so many more mycotoxins than they used to be, because I remember cows today are eating double what they were 20 years ago. They're eating so many different byproducts from all over the country. So they're not exposed to mycotoxins and pathogens just from their regional area. There's cows in Ohio that are eating DDGs from the Northeast.
Oh, yeah.
So it's just a different environment. And so what's happening is that there's more mycotoxins present, and mycotoxins are getting built up in that intestinal cell faster than what the intestinal cell can kick them out. And this will cause cell death. So mycotoxins are causing cell death, kind of punching holes through that castle wall. And mycotoxins are also breaking down your tight junctions between those cells. So kind of just like the mortar in between the bricks and that castle wall. So you kind of have a double effect, where mycotoxins are killing those cells, but then they're also kind of weaseling in between the cells as well. And they're punching holes. This also allows just other pathogens to go through that are opportunistically seeing that hole, and they go through and enter the bloodstream, and the cow has to deal with it now.
I mean, that's what leaky gut is, right?
Yeah. And whenever people talk about leaky gut, which is being discussed more, just what they mean is pathogens being able to either go through tight junctions that have broken down or pass through intestinal cells that have either died or they have found ways to get through.
So go ahead.
Back in the intestines, that's where we need to stop the mycotoxin from being able to go through in the bloodstream. Because once it's in the bloodstream, she has to mount an immune response to take care of those mycotoxins. It's very energetically expensive. So instead of using those nutrients to make milk for reproduction, She instead has to shift them to protect herself. It's also hard on the liver because the liver has to detoxify them, and the liver has a lot of jobs to do.
Yeah.
And then we're asking it to also detoxify mycotoxins and deal with the repercussions of different mycotoxins in the liver. All the products, the mycotoxin protection products, what they're all trying to do is to stop the mycotoxins from getting into the cow and into the bloodstream. So we know there's just a breadth of research knowing that's where mycotoxins are getting in. Now on the ruminant, we also have the rumen.
Yeah, I was going to ask you to
Yeah.
touch on that because I mean the rumen's able to do there's billions and billions of microbes there. They're able to do a lot of breakdown of a lot of different things. So are we getting mycotoxin degradation? Like in particular, I think of zearalenone, T2, Fumonisin that we see regular in their sampling programs. Are we getting some breakdown in the rumen?
So the rumen is capable of detoxifying some mycotoxins, but you also have to remember too, mycotoxins were made by molds to harm other organisms. Mycotoxins are bactericidal and protozoacidal. That means they are able to kill bacteria and protozoa. That's the bulk of the rumen microbes, or bacteria and protozoa. So as we have a higher and higher concentration of mycotoxins, they're more able to overwhelm those bacteria and harm them. So that's why when we have high DON diets, we see digestive issues. We also see inconsistent manures, loose manures, and this is because the mycotoxins are killing those fiber degrading bugs. Mycotoxins also do cause diarrhea too. They mess with sodium transporters in the intestines, which then pulls water in and causes diarrhea. So in the rumen, the rumen has ability to protect itself, but cows are also different than they were 30 years ago when they were probably doing a better job at protecting themselves. I said before, more mycotoxins, multiple mycotoxins present. It's just a higher concentration to deal with. And one thing I think we don't discuss enough as well is the rumen environment has a very big impact on its ability to detoxify mycotoxins. We know that high starch diets or acid diets that can cause some acidosis are going to lead to less degradation of mycotoxins. And a lot of
passage, right?
Yeah, well, part of it's rate of passage, so you have a higher rate of passage. So there's just faster rate of passage. So there's just less time to degrade them. But also, there's some really nice work done in the 90s that found that in vitro, so in a lab, they had rumen fluid and they put in a known amount of mycotoxin and then they incubated it at different pHs. So once you got to pH of 5.2, DON degradation completely stopped. There was none. So we can't compare it one-to-one to a cow because it is a lab environment, but we do need to realize we probably have many cows on farms whose rumens are getting into those low 5 pHs. So maybe we're not completely shutting down DON degradation, but we might be slowing it. We are definitely slowing it. So cows need starch. They need the energy to make milk. It's an excellent choice to feed the starch diets, but we need to be aware of how it's going to shift what the rumen does. And it's probably reducing the amount of DON that can be degraded in the rumen. And we need to mention too, Fumonisin is not degraded in the rumen at all. It doesn't matter what the diet is, what the pH is, there's no Fumonisin degradation in the rumen. And zearalenone too, it's passing through and it's interacting then with the intestines.
I'm glad you brought up Fumonisin from the standpoint of we see a lot of forage samples come through Dairyland Labs. And I'm going to say Pennsylvania, Maryland, Virginia, North Carolina, if you are dairying or feeding cattle in those states, please check your forages. You may have some DON issues. You may find some zearalenone, but we have seen astronomically high Fumonisin levels that I've never seen before in the 4 years that I've been with Agrarian, and as well as the previous 7 years that I spent with Select Sires doing forage sampling with them through Agrarian. And Fumonisin, this is a fun little fact that Dr. Roth taught me, but Fumonisin is used in human medicine, Caroline, as an anti-rejection drug in transplant patients. So if you're using an anti-rejection drug, what is your purpose as an anti-rejection drug, suppressing the immune system. So keep that in mind. Please, like, email us at agrsol.com. I will send you some sample bags, but there is a lot of concern, I think, especially in the East Coast samples that we've seen, Fumonisin levels being extremely high.
Yeah, and the rumen doesn't degrade Fumonisin, and Fumonisin does harm tight junctions. So that's how it gets its way in. And then Fumonisin's really hard on the liver. It causes cell death in the liver, just not as bad as aflatoxin, but it's up there. And so, yeah, if you start seeing odd metabolic issues, it's probably because Fumonisin's harming the liver, harming its capability to make glucose for the animal.
Right.
Yep. And just general, immune issues, like you said, immunosuppressive. And yeah, it's going to cause leaky gut and some other issues there with pathogens getting in.
We've talked quite a bit in the last number of months since we've started Ruminate this idea of utilizing clay type binding ingredients that we dig out of the ground and yeast cell wall. And we've cited research done by the Cajal et al. Group there out of Spain. And yeah, probably if you're dealing with aflatoxin, folks, I don't care where in the world you are, feed a clay. It's very effective. But if we're talking DON, and we're talking Fumonisin, and we're talking T2, and we're talking zearalenone, yes, there are some of those products, I should say ingredients, that can be somewhat effective against those things, but in general, not very efficient way of mitigating mycotoxins. And
yeah, I'd say they're marginally effective.
Yes, and we've covered that,
yeah.
And I don't want to spend a ton of time on that today, but the one thing out of your presentation at Penn State that I thought was interesting was enzymes. Talk to us about enzymes and maybe some, I guess, evidence of what enzymes are able to do, because we do see more and more products that say, hey, we have enzymes. So give us an enzyme lesson, if you would, Caroline.
Yeah, there's some products, they have their enzymes patented, so they're the only ones with the enzyme that are effective against zearalenone and Fumonisin. And they do seem to work pretty well, but you got to remember, with an increasing concentration of mycotoxins, you need more of that enzyme too, because it's one enzyme molecule, one mycotoxin molecule. It transforms that mycotoxin and then it's done transforming things. So increasing concentrations, you need more.
And when you say transforms it, like transforms it into a non-toxic metabolite?
Yes.
Okay.
So there's some certain parts of the chemistry that I don't understand well enough to get into. There's some,
that's fine. But like just in layman's terms, yeah.
Yeah. So the enzymes, they are attacking certain parts on that mycotoxin molecule and just changing a few of the bonds and making it non-toxic. And they're really cool if you do dig into the chemistry. And they are effective in ruminants. There's less evidence for their effectiveness against DON in ruminants. Honestly, I haven't seen studies where they're effective against DON in ruminants. They have some different strategies that do seem to work in monogastrics, but when in the rumen environment, they just don't work against DON. But you got to remember too, like I said, patented products, not all enzymes are created the same. And you need to know how much enzyme is in the product. So what is the proper feed rate depending on the amount of mycotoxin you have?
Yeah,
and they're super specific too. They're not broad range.
Okay.
So we know that if you have zearalenone, you probably have quite a bit of DON too.
Yeah, they seem to run in tandem in a lot of cases. A good way to think about it is DON is really like a marker type toxin. Like if you have DON, you probably are going to find something else.
Yeah.
So I guess we've talked, again, we're not going to spend a lot of time on clay and yeast cell wall today, but enzymes at a field level, we have the fungicide, which it sounds like can be effective if applied properly, but you have to hit that corn at the right time and
fill applied perfectly, which is almost impossible to do. But it's
right. Yeah, on a small scale, if I was growing 15 acres, it wouldn't be a big deal. If I'm growing 1,500 or 10,000 acres, that's more of a challenge.
Yeah.
So then the last thing in your presentation you touched on was the idea of mycotoxin-specific probiotics. which we happen to know something about, I guess you would say. So talk to us a little bit more about our mycotoxin-specific probiotics and why there might be an advantage there over other mitigation strategies.
Yeah, this is where DTX comes into the story. We grow our bacteria to be specific against mycotoxins. So there's a lot of probiotics on the market. They are good products. They're do different things. Different bacteria strains do different things. Ours is grown to stop mycotoxins. What we believe is that we are interacting with those natural mycotoxin defenses I talked about. We're helping the intestinal cells much quicker get those mycotoxins out of the intestinal cell and back into the intestinal lumen. We're stopping the mycotoxins from getting into the animal. And then we do think we have some action in the rumen, because we talked about, what we see when there's a lot of DON in the rumen. We see and other mycotoxins. We see inconsistent manures. We see reduced milk components because of reduced digestion. And once we start feeding DTX, if it's the mycotoxins causing those issues, it recovers fairly quickly. And it makes sense because we're growing our bacteria and teaching them to seek out mycotoxins for their carbon nitrogen.
Yeah, and when you say fairly quick, I mean, I've heard this over and over. This is not me making something up, but I heard it again this week, Caroline. I heard it again Monday. Like within 72 hours, the manure straightened up.
Mm-hmm.
That's pretty quick.
Yeah.
And
so if it's the mycotoxins causing that issue,
yeah,
DTX helps clear it up.
Yep.
Pretty quickly.
So before I let you go, Caroline, I think just recap for people, because we kind of bounced around a little bit, but we have mycotoxins in the field. They don't mean us any harm, right? They're just trying to survive themselves. We then harvest that corn or small grain. We put it in storage. And from there, we really don't have a chance to reduce what we bring in. But explain again, like with the strategies, just to recap, what we can do to help prevent increase in mycotoxin growth.
Yeah, packing as much as you can like crazy, getting the oxygen out of your feed bunk. So packing with the proper amount of weight, applying if you want to use an inoculant, lactic acid bacteria-based inoculants are excellent to reduce the pH quickly and help prevent mold growth. It's any strategy to prevent mold growth. So you're preventing the molds that are going to make the mycotoxins. Anything to stop those molds will help prevent an increase in mycotoxins. And consistent sampling too matters too. Just sampling as you move through that pile so you know what's there, because it will change throughout the pile because you have different fields going in and different layers. And it's important to know what's there so we know what strategies to employ.
It's funny you mentioned that because, the old saying, right? The only consistent thing about mycotoxins is their inconsistency. They're not distributed evenly in the field. They're not distributed evenly in the bunk. I do think our modern bunk storages or pile storages, I think that does help kind of distribute them more evenly throughout the pile than maybe an upright silo or an ag bag. But I've seen it myself where, we forget about the toe of the bunk. You get into the bunk, you sample, and 2 months later you sample again, and it's kind of a different number. It's just not always consistent. So that's a good point. And the enzyme stuff that you talked about there in your presentation at Penn State, I'm intrigued by that. I think that's pretty cool technology. If I'm a producer though, and I'm considering going that route, you kind of said it, but I'll bring it this way. I would caution against, I'm going to say window dressing, and I don't know specifically of any product out there that is doing it, but just be cautious. Like make sure you're selecting a good enzyme that's doing what you're wanting it to do.
In the amount that is necessary to do the job too.
Yeah.
Because you can add a little sprinkle of enzyme into a product. I don't think this is happening, but it's definitely, you can do it with any type of enzyme, but
sure.
Yeah, it needs to be in biologically significant amounts so that it actually has the wanted impact on the animal.
Yeah. Yep.
So yeah, they're really cool products. It's just you need a specific amount, and They are very specific against just a couple mycotoxins. They're not broad range.
And then, lastly, with our approach of the mycotoxin specific probiotics, I like to tell people the cow has the ability to do the job herself. And we're just kind of helping her do the job herself, right?
Letting a cow be a cow, use what she already knows how to do. We're just ramping it up a little faster.
Yeah. Well, Caroline, I appreciate you taking the time out of your day today to visit with us on Ruminate This. As always, folks, if you found value in today's call, please just click on the link, share it with a friend, subscribe. The greatest form of flattery we can possibly get in this space is by you. Hey, this call had value today. I'm going to send it to somebody, send it to your nutritionist, send it to one of your clients, maybe, or a veterinary, or just a friend that you think would find this interesting, because I think we definitely appreciate the people that are listening and supporting us here at Ruminate This. So, Caroline, with that, I'm going to sign off for today, let you off the hot seat. And once again, thank you so much for joining us.
Thank you.
All right. Have a good week, everybody. If you found value in today's podcast, please hit subscribe and share. And we look forward to talking to you again next week.